texting, unlimited everything, and that costs $67 a month. Are there any other charges involved? No, it's unlimited, $67 a month. So one equation would just be y equals 67. It costs $67 a month, we get the same text plan all the way along. For the other texting plan, let's say it's cheaper. Let's say our second option is $40 a month plus 20 cents for every text that we send. So if we send one text, it's going to cost us $40.20. If we send two texts, it's going to cost us $40.40. So that makes sense to everybody? So what I'm putting in as my independent value is how many texts I'm going to send, or how many texts I do send. What I want you to do right now is I want you to put y equals 67 in your first line, and y equals 40 plus 0.20x or 0.2x, same thing. You might have to move your window over a little bit, or you could just go to calculate. And I want you to find at what point would I be better off to go with unlimited. How many texts would I have to make before it would be cheaper for me to go with the unlimited plan? One thing I want you to notice, excuse me, y equals 67 is going to be what kind of line? I don't know either. Let's graph it. My window is too little, so let's make it bigger. Because I just said y is 67, my window only goes to 10, so I might need it to go higher. What kind of line is it?
Straight line.
It's a straight horizontal line. There's no slope to it at all, is there?
No.
Because there's not even an x value here, so there's no slope. So it was a straight horizontal line. It's the same no matter how many texts I make. Okay? Then we're going to go back in. We're going to enter our other line. So 40 plus 0.2x. And it looks like they're going to connect, right?
What did you change your window for the X too?
I did.
What did you put it as?
Right now it's 100, but we're going to have to change it again. Because look, I can see that they're going to connect somewhere, but it's going to be like right here, right? So I only go out to 100 texts right now. I could make more than 100 texts before I'm going to break even. So I'm going to move my window, because remember X is the number of texts I'm sending. That was my independent variable. So let's just change it to like 200 and see what happens.
And both the maximum.
I only changed the X. I only changed the number of texts. Alright, so what we have is we have our straight line problem that represents unlimited texting at $67 a month. And then we have our variable problem that represents paying per text. So $40 plus 20 cents a text. So at this point, this is my cheaper plan. And the top plan would be more expensive. Remember, this is unlimited and then pay per text. So unlimited is more expensive until we get to this point. Once you've made that many texts, then the pay per text plan gets to be more expensive and the unlimited is cheaper. Can you see that?
Yeah.
So that's a great thing to know. Let's see then
135.
exactly what that point is. If we calculate our number 5 intersect, and then remember we have to hit enter 3 times. So we have the first line, the second line, our guess. It tells us that those lines intersect where x is 135 and y is 67. It's got to be, that was our choice. Where 135 represents what again?
The number.
How many texts? So once I make 135 texts, I'm exactly even. At 135 texts, it doesn't matter whether I'm on the unlimited or on the other plan, I'm paying exactly the same amount, $67. Once I make 136 texts, this becomes the more expensive plan. So if you're going to make more than 136 texts in a month, then you would be better off on the unlimited plan. Which is why, how many of you are on plans that have texting where you pay per text? Anybody?
Don't have a phone.
There you go. So not you. No. How many of you have plans where your texting is unlimited? Right, because your parents made that decision going, dude, you're gonna make more than 135 checks. I'm not paying that extra money for it. Solving by graphing. Questions about solving by graphing? We put everything in our y equals, our two different equations. We graph them. We might have to mess around with our window a little bit to make it fit the numbers in our problems here. And then we can just go second, and then get to calculate, find the intersects, number 5, enter, and it's going to tell you what your x and y answers are. Who thinks they can do that one? Good, good, huge. All right, the second method then, in our notes that we're going to look at, is table. And we can still do the table on our calculators as well. To use a table on our calculator, we would do exactly the same starting points as we did for the graphs. So you put your two equations in your y equals. That part's really easy. And then instead of hitting the graph button down here, we're going to hit second graph to get to this little yellow table. So you're going to hit second and then graph. And then we have a table, and I'm going to slide it up a little bit to see if we can find a spot where we're not so glary from the bright morning sunshine here. Because I think it'll be too dark with all the lights off. We'll try it. I'm waiting. I'm still waiting. Okay. So, what we're doing when we're looking at our table is seeing these are the independent variables. These are the different number of texts they're plugging in. So if you put in 50 texts, the unlimited plan still costs you $67. The variable plan would only cost you $50.20. If you put in if you made 57 texts, unlimited, $67. The variable plan, $51.40. So what you're going to do is just scroll down until you get to a point where you see that the second plan, the variable plan, costs the same as the independent plan or the constant plan, or where you see that suddenly the other plan is going to be even more than the first plan. You could go in and change your table to start at a different point, or you could just keep arrowing down depending. We're pretty close now, so we're just going to keep going this way. So here, you can see they're getting closer and closer. This one's 67, 67.40, 67, 67.60, 67, 66.80, 67, 67. So again, same answer we just had before. When we make 135 texts, our plan is going to be exactly the same, $67 for both. So when you're looking at a table, you're looking at what x value are both y values from the first equation, y1, and the second equation, y2, going to be exactly the same. See that? If we went back to our y equals and we put in that first equation we had a few minutes ago, which I think was 2x plus 5 and x plus 2. So do that for a second, and we'll make sure that we can still find a table. And then you're going to go back to your table, and you will notice that we are still at that 130 something we were at a minute ago. Does anybody remember what the answers were for that? Okay, Rachel, are you stuck?
Mine's only by 2s.
Okay, we'll fix it. Ready? If you remember a minute ago, our answers were like 1 and 3 or something like that. -1, -3, something way smaller than 130. So, what we would do to fix our table so we're not starting so high, because we know that's a crazy answer, or if you're going up by 2s, same fix, okay? You're going to go here to second window where it says table set. And we're just going to change the setup on our table. So in this case, the table starts at 130. let's start our table at like -5. I picked -5 because when I graphed it, I saw it was a little negative answer, and I thought, I don't think it's more than -5. And then this little delta table is your change. So delta represents change, so you're going to go up by 1s if you change that to 1. Yours probably was 2. If you wanted to go up by like 0.5, you could put 0.5 in there and go up by a decimal, and that would work as well. Now when we go back to second graph to get our table, you can see that we're starting at our nice -5. So we have -5, -4, -3. These are all our input values. And we're looking for a place where both of the y answers are exactly the same. So you can see that when we had an input value of -3, both of our y answers were -1. So the point where those lines would intersect would be the point -3, -1. We could have arrowed up or arrowed down, I guess, until we got back to -3, but we were at 130 and that takes a really long time. So if you want to be able to jump faster, remember at second window, and then you can change your setup to start at whatever point you want, and to go your table to go up or down by whatever number you want, even a decimal. Questions about tables or graphing? No questions. All right, then the last of our notes for today are on solving systems by substitution. So we won't need our calculator to solve by substitution because we're going to do them mathematically when we solve by substitution. When we solve by substitution, we're going to take our problems. So here were my two problems. 3x plus 5 and 2x plus 7. Substitution essentially means that I'm going to take something that it equals, and instead of putting y here, since I know y also equals 2x plus 7, I can substitute or exchange the 2x plus 7 in for that y. And I'm going to give you a second to write that down. And I'm loving how some of you are sleeping. And I just want to remind you that that means the Boyer and I are not going to be assisting you in your endeavors as you are working on these problems. So heads up on that. Okay. So essentially, if I plug in the 2x plus 7 in place of the y, I'd end up with the equation 2x plus 7 equals 3x plus 5. And now it's basically one of the problems like we've been solving all along. Your goal now would be to solve for x. So to solve for x, one thing I might do is subtract 2x on both sides. If I subtract 2x on this side, it cancels out. On this side I have 3x minus 2x. And I kind of skip a step here because I'm getting good at solving. So I took this and said, okay, well then I'm going to subtract 5 from this side and this side. So I try to subtract 5 from this side, it cancels out. When I subtract 5 from this side, I have 7 minus 5. Well, 7 minus 5 is 2. And 3x minus 2x is just x.
Can you do, instead of minus 2x, can you do minus 3x?
You could. And then do minus 7. You get the same answer. And so now, if we were solving that problem, we have the x value. So if this were our equations, our answers are always going to be an ordered pair. And we know that the x value is 2. We need to solve for the y value in order to get the answer. And you could check your work by plugging 2 into both of these equations. So if I put 2 into this equation, I'd have 2 times 2, which is 4, plus 7, which is 11. If I put 2 into this equation, I'd have 3 times 2, which is 6, plus 5, which is 11, so I know 2 is the right answer.
Why do you have to do like the opposite number, like 7 and then 5? Why do you have to switch them?
You're trying to get x on one side and then numbers on the other side. So if I move my x's to one side, whatever side I move them to, there's a number on that side in this problem as well. We're trying to move that number then away from the x.
So you can do like switch them every time.
If it's set up like that, you'll have to switch them both. Yeah. The x to one side, the number to the other side. Okay. When you plug that 2 back into the equation, so I plugged it in, I got 6 plus 5 equals 11. I plug it in, I get 4 plus 7 equals 11. Essentially what we're finding then, when I put a 4 in, or 2 in here and get 4 plus 2, we get y equals 11. So the other part of that equation then, or that ordered pair that we're looking for, is y equals, so the x equaled 2, the y equaled 11. So you could have solved this problem by graphing. Slide down, G. You could have solved this problem on a table. Or you could solve this problem by substitution. No matter which way you did it, you would get 2 and 11 for your answers every time. Alright, I have one last problem and then we're done for the day. Okay? So the last